Hey, welcome. Every single day we're swimming in this ocean of information, and somehow it all feels, well, easy. Almost like magic, right? But what if I told you it's not magic at all? There's this whole fascinating field working behind the scenes, making sense of the chaos. Today, we're going to pull back that curtain and explore the invisible discipline that designs our digital lives information science.
I mean, just stop and think about that for a second. With a few taps on a screen, you can find a recipe, pull up a complex scientific paper, or watch a video from the other side of the planet. How is that even possible? How does a search engine dig through billions of pages to find that one thing you're looking for? Well, I'll tell you, it is absolutely not an accident. It's by design.
And that really gets to the heart of it, this incredible paradox. We are creating an unbelievable amount of data every single minute. It's an explosion of information. And yet, somehow finding what you need feels simpler than ever. This is the exact problem that a very specific field of study was born to solve. And that field is, you guessed it, information science. It's kind of like the quiet architect, the invisible hand that takes all that messy, chaotic information and builds the clean, intuitive digital world we live in every day. So let's get right to it. What is information science, really? Okay, so at its core, information science is basically the study of, well, information itself. And that's a way bigger idea than you might think. It's not just about computers and code, it's about the entire life cycle of information, from the moment it's created to how it's collected, classified, stored, and, most importantly, how we get it back when we need it. It's a field that's all about the big picture. Now check this out. What's really wild here isn't just the definition, but that date, 1968. That's before the moon landing, way before the internet was a thing for any of us. But just look at those words: optimum accessibility and usability. That's it. That's the mission, and it's been the same goal from the very, very beginning. And that beginning, well, it started a long time ago. The history of this field goes back way further than most people realize. We all tend to connect it with the digital age, but the fundamental challenge, how do we organize all our knowledge, is much, much older than the computer. This timeline just blows my mind. We start in 1801 with a loom. The Jacquard Loom used punched cards to store patterns. That's basically a physical hard drive for weaving. Then, 1854, George Boole comes up with the math that powers every single Google search you make today. But the showstopper, for me, is Paul Otlet. In 1895, this guy was dreaming of a global network of hyperlinked documents that anyone could access. He literally envisioned the World Wide Web before radio was even a thing. It just proves that the problems are ancient, that it's only our tools that are new. So if this field is so old and so massive, how does it all fit together? What's holding it up? Well, it's not really one single thing. It's more of a bridge, a modern discipline that's built on three really solid foundational pillars. And here they are. You've got the technical pillar, right? That's all the heavy lifting from computer science and data science. Then, in the middle, you have the centuries of wisdom from library and archival science. These are the original masters of organization. And then, and this is so important, you have the human dimension, understanding how we think, how we behave, how we interact with all this stuff. Information science isn't any single one of these. It's the thing that connects them all. Okay, so that's the history and the theory. Pretty cool. But this isn't just some abstract idea you'd find in a textbook. These pillars support things you are using every single day, probably without even realizing it. So let's look at where you actually see information science out in the wild. All right, first up, information retrieval. Literally every single time you type something into a search bar, boom, you're using an information retrieval system. This is the science of battling information overload. It's not just about matching words. It's about figuring out what you actually mean, your intent, and then ranking billions of documents in a split second. It's the engine that powers our entire digital world. Have you ever been on a website or used an app that just worked? You just instinctively knew where to go, where to click? That amazing feeling is the work of good information architecture. It's the art of laying out a digital space so that it makes sense to a human brain. It's the invisible blueprint that stops the internet from being a complete and utter mess. Now this one sounds a little sci-fi, but it's happening right now. Knowledge representation is a part of AI that's trying to get computers to understand information, not just store it. So for example, it's not just about teaching a computer the letters C-A-T.
It's about teaching it the concept of a cat, that it has fur, it has whiskers, it purrs. That lets the computer make logical connections, and it's what takes us from a simple search engine to something a lot closer to true artificial intelligence. So when you put it all together, the history, the theory, all these real-world applications, you start to realize something. This isn't just some small academic field. The people doing this work are, quite literally, the architects of our digital world. They are building the reality that you and I live in every single day. So look, if you take away just one thing today, let it be this. That seamless, effortless feeling you get when you find exactly what you're looking for online, it's not magic. It is the result of decades of careful, brilliant design by information scientists, architects, and librarians working behind the scenes to tame all that chaos for us.
And that really leaves us with one last big thought. We're creating more information, more data, more complexity every single second. This problem is only getting bigger. So the real question for the future isn't just how we're going to manage it all, but who. Who are going to be the next architects to build the systems that can make sense of it all?